This will be a 1-hour session in which we will discuss SOALIB for cloud computing. The presentation materials and the video of this webinar will be available within a week. After this webinar is over, what we usually do is we videotape the webinar and then we do some editing on the video so that the video is compatible with the web. In this webinar, I will discuss and focus on cloud computing in general and then give some overview of SOALIB and how it can be used for cloud computing environment. In cloud computing, the word cloud means network. What is cloud computing then? It's a service-based computing model where applications are hosted on networks where the cloud provides application hosting environment with elastic resources. This model is not new, and you know that the green screen terminals which existed in the past to host server-client application. Then why reinventing the wheel? Cloud computing scales the hosting platform itself. This was not a model that was used in the past. For example, if at the beginning there is a need for 1 or 2 servers, then one may purchase the server and host the application. But as the usage increases, more servers have to be purchased. This requires both money to purchase the servers, more bandwidth, more power, space to store the servers, people to maintain the servers, and many other things that is related to scaling the applications. Presently, there are already 2 most popular cloud environments available: the Amazon EC2 and the Microsoft Azure. Probably you have already heard of that. Others are also there, but not as popular as Amazon and Microsoft Azure. Why would someone like to host on the cloud? Business may purchase servers, host their application, and then offer them on the internet. This is the model always used and will always be used. But could cloud model have some of the advantage when there is a need for scaling the application up or down? Hosting applications on the internet have some cost saving, but at the same time, expenses of other related costs also add up. Before going into the advantages, let's focus on the cost. A 1 or 2 server-based hosting is simple and easy. That does not need a lot of power or bandwidth. But as applications are consumed more and more by users over the internet, there is a requirement for more servers. Installing, configuring, and connecting the servers on the network in a data center. Time, money, and other related issues like space, electricity. These are all related issues. Cost of electricity, bandwidth, and disaster recovery requirement increases. Considering all the above facts, cloud computing, in fact, saves quite a bit of cost because the cloud hosting companies deal with server availability, electricity, bandwidth, server space, server modification, server upgrade, and other physical resources. The application now only have to deploy deployed into the host, and that's it. If at any time more servers are needed, then one may have more available on demand. At any time, On a cloud environment, multiple servers can be made available, or multiple servers can be removed at runtime or using a web API. Cloud assures the following: scalability of physical hardware, scalability of network bandwidth, and minimum downtime. Applications written for the cloud are usually based on service-oriented architecture. These software only have to be written just once and then deployed onto the cloud. This makes the application scalable, integrable, as well as consumed by clients over the network. Sorry about this pop-up window. Computing. Cloud computing uses grid computing architecture. Now let's focus on what really is grid computing. In this slide, I have attempted to show how an electrical grid works. The power generation stations are very diverse, as you can see here. The power generation stations may be solar, nuclear, or maybe bio. Regardless of how the power is generated, if the power is fed to the grid, it is consumed by the consumer. The power generation plants only feed power when they are consumed. The direction of the power flow will be from the power generation station to the consumer if the consumer needs the power. On the other hand, it will be back to the power generation station if the power generation station is itself consuming the power. The direction of the power flow will be from the power generation to the consumer if the consumer is power hungry and consuming the power more and more than the plant requires. Now, how is it related to grid computing? In cloud computing, resources are scaled in a similar way, just like the grid computing, grid and electrical grid. Now, power stations are replaced by hosting servers, and the high-tension poles are replaced by routers. The consumers may now access any host from their network. If at any moment the services offered by one of the service providers is loaded, then the service could be scaled by requesting the service to be processed by another host. How is this done? There are various methods in doing that. One way is virtualization. In this slide, you may notice that a new logical server is created, which is the light green background. The virtualization hardware and software merges the two servers into one without the knowledge of the client. Of course, the client has to request for it. The logical server may scale memory, disk space, processors, and bandwidth. I/O and other resources can also be scaled. This is a simplified view. Many of these are now done by software and hardware, and including the processor itself. New Intel and PowerPC chipsets have built-in virtualization hardware built into it into the instruction set. Virtualization. Virtualization creates virtualized resources into a system. The word virtual means simulated. That means if more memory is needed, for example, then additional memory could be made available by either creating memory by using I/O devices like hard disks or by allocating more physical memory. From the perspective of the client, it does not matter how memory is created. What the client sees is that there is more memory available. Similarly, disk space could be virtualized by adding multiple physical and logical drives. A virtual system makes use of one or more processors during execution. Similarly, a system with more than one network port. Each virtual system may be created with various combinations of network ports, each having its own network ports and IP addresses. Virtualized systems are such that one does not know the existence of the other, even though if these virtualized hardware are within the same system hardware. In hardware virtualization, the virtualization is done within the processor. In software virtualization, the virtualization is done within the software, which sometimes make use of the hardware if needed. I/O ports like video, printer, keyboard, etc. could also be virtualized so that each virtualized system have its own video, printer, keyboard, etc. Just about anything can be virtualized. In this simple example of virtualization, we have a system with 8 processors, hard drive, and memory. We can create 8 virtualized systems by making use of one processor per memory per hard disk. Or we can create virtualized servers by mixing various numbers of processors, memory, and disk drives. The latter is the true advantage of virtualization, as we can scale the system either at runtime or install time. SOA on the server side. SOA is service-oriented architecture. SOA on the server side gets loaded as clients consume the service. So what really is SOA? SOA is the application platform written for the cloud. And these applications loads the server as they are consumed by the internet client. A service must always be available by all means, because as you have noticed from various cloud applications already out there, if a server gets loaded, the response time slows, and you do not want a cloud environment where as the number of users increases, your application speed suffers. Definitely we need a solution which scales based on users, and as more and more users are added into the cloud to consume the same application, the underlying hardware and resources increases based on the scalability model. In this line, servers get loaded as services are consumed. The first line. The second line, services must always be available. We do not want to have a situation where there are so many clients that the service is no longer available. Services should never run out of resources. In cloud, resources are always available, and resources could be created virtually by using various API that cloud computing offers. The bandwidth for services should be uniform. That means that if the number of users increases, the bandwidth will remain constant. The bandwidth means that if we have a 10 gigabytes bandwidth, for example, we must ensure that this 10 gigabyte bandwidth is available regardless of how many users are consuming the services. To do this, most of the time, the cloud services or the cloud-based applications are globally diverse. Services should automatically scale with consumption, as obviously services are applications, and these applications must also scale itself if the number of consumers increases. The response time for services must be predictable. We do not want to have a case where there is a one user and the response time was 1 millisecond, and there are 100 users now. The response time becomes 100 milliseconds. In an ideal case, if there is a one user, with the response time will be 1 millisecond, and if there is a 1,000 users, the response time will remain 1 millisecond. Services must act indifferently from whatever or wherever it is called from. Obviously, we have many different kind of clients. We do not want to have a case where the client, for example, from a mobile phone, calling the service will be slower than one calling from the PC. The response time to the service and the client should be indifferent. The complexity of all of the above must be hidden from the service consumer. That means that whoever the consumers are, it may be mobile system, it may be internet applications, maybe websites, it may be web application or PC application, it does not really matter. The consumer does not really have to know what is the complexity of the cloud. This shows an application platform on the cloud. Consider that the background is the cloud and there are services being offered like data services, industrial services, consumer services, business process, programming languages, device services like mobile phone, legacy application, global services. All these services are running into the cloud. And remember, what we mean by cloud is really a scalable platform. And all these services are running in scalable platform. That means the cloud. Now, how easy it is now. Looking at this slide, that all of these applications now running in the cloud, now they can communicate with each other very easily because we have now moved these applications from each PC or each individual server inside our intranet to the internet. And because each of these internet applications are located into the cloud, one can interact with other without us thinking about hosting our own services into our own servers. We do not really have to maintain servers. These are now cloud applications. And this is where we now hear about interoperability and integration. Cloud computing is one of the best ways to integrate and interoperate with other network applications. Cloud applications. Let's go over a little bit on how cloud applications work. Now, cloud applications can be anything. It may be a website written in possibly PHP or HTML, or probably .asp or JSP site. Now, those are traditional. We really want to have applications to do something useful. Website, web application provide request response type of application. We want to have something more. For example, we want to have a banking system entirely or accounting system entirely in the cloud. Or Salesforce, for example, uses CRM entirely on the cloud. All we have to do is connect to the website in salesforce.com. Or consider another example, WebEx, which is web data exchange format or webinar, where you can host presentation and materials, other things that I am doing right now is presenting a webinar over the web, can also be a cloud application. Now, how are cloud applications run? It's based on service-oriented architecture. A service-oriented architecture is very broad. It does not mean just web services. It means anything that is based on this model. And in this slide, you can see that those little Lego pieces are small services on which the two output services called A and B are created. And these A and B services are exposed from the cloud. But it depends on two layers of other services. And notice that the two layers does not have to be in the same server. It is distributed to other clouds environment. And each of these little Lego pieces in multiple layers may be other companies hosting the cloud service. So what is the advantage of doing things like this? Things like this has one very clear advantage, is that each of these service components, which you see in each layer, are complete services offered by companies which have expertise in that particular area. For example, CRM. CRM, to use our own cloud software, we probably need to use CRM. And one of the examples of using very good cloud environment offering CRM is Salesforce. And we can just use Salesforce CRM services in our own application. And we do not have to write our own CRM application. Similarly, banking software. If we want to have an internet bank, we can just use banking services from established banks. Stock code or stock trading. There are services out there which allows you to trade stocks. All we have to do is consume those services exposed over the cloud. So what is the real advantage? The real advantage is all these complex applications are already written for us to write an even more complex application. which we would expose as services. And the clients can consume our own services from the cloud. And in addition, other applications that require our services can also consume our services. So there is a constant revenue stream which can be generated by using cloud applications. So there is clearly a business need for why cloud is so important. This is a slide, more technical in nature, tells you how clouds distribute resources. In this example, you see consumer 1 is calling a service named A. A depends on another service named B, but B is scattered around the cloud, and that's where we are talking about scalability. B can use any one of these available B services available on the internet. As you can see, this arrow, and there are 3 B services, and there is also 1 B services on the internet. And any one of these B services can be used by A. This decision is based entirely by the service, and as you can see, B relies on C, and C can be always distributed like it is in B. SOA in the cloud. Service-oriented architecture are tied to ESB, Enterprise Service Bus. The line you see, the orange line you see at the center, may be considered as ESB. Each ESB appears as a port on a network which is connected to the internet. An imaginary line could be drawn to represent connectivity among various clients, which really is the combination of all the exposed network ports. There is no physical wire that is connecting this orange lines. This orange line is basically IP addresses and ports. So if service A would like to consume service F, then it goes out of its own port and then enters the IP address of F through the port that is exposed on the internet. The F service then processes the information which the consumer provides, and then the return path is the same as it went to F. This model is similar to what really happens now. There isn't much difference. And this is the execution path. On the right side corner, you see service call sequence. In the service call sequence, we have A, B, C, D, E, and F. Each of these services called sequentially. And the execution path is a service A calls service B, and you have seen that service B is stacked. That means B is virtualized. Similarly, C is also stacked. That means C services are virtualized. Similarly, D is virtualized, E is virtualized, F is virtualized. Virtualizing is required for load balancing. And you can see that in the real cloud, A, B, C, D, and E, and F does not really have to be on the same server, and they can be very geographically dislocated locations. And they may be operated by different companies, different countries. And that's the advantage of cloud computing, is that we just consider the entire cloud, which is the network, as all connected services. You have heard probably of SaaS, Software as a Service, a model used over the web, is based on service-oriented architecture. In this slide, we are showing that this orange curvy line which we saw before is now exposed as HTTP using a SaaS model, Software as a Service. Software as a Service is a model which exposes the software over the web using HTTP primarily. On the other hand, SOA is the architecture on which SaaS applications are built on. Now, this concludes the introduction to service-oriented cloud computing. Now, I will focus on some real applications that run on the cloud and help build your own cloud applications. Now, as you know from our discussion, that cloud allows you scalable platform in which you deploy application and do not worry about how the system scales. And it has an inherent advantage that these applications are written in a single focus, with a single focus that it will solve a business problem. In a cloud environment, we do not have to worry about what is the programming language, who are the clients, what is the hardware platform. It does not have to be even thought when we are thinking about cloud applications. We just focus on our applications from the perspective of the client. SOALIB, which is the company, provides application and libraries to build your own application for the cloud. And these libraries are operating system and independent. Programming languages may be used: Java, C#, C++, C, and .NET. All these client applications can consume the SOALIB services. SOALIB services on the server side is written entirely in Java. That's why most of these services can be deployed on almost any kind of servers, any processors. SOALIB services can be hosted on multiple application servers, can be Oracle application server or WebLogic, WebSphere, Tomcat, JBoss, etc. Hardware platforms may be any kind of hardware. Because it's in Java, it does not really matter what the underlying processor is or the hardware platform is. Mobile platform ready. SOALIB can be consumed by mobile devices. For example, a cell phone can consume SOALIB services. SOALIB provides the API for consuming SOALIB services from mobile devices. These API is written using C for iPhone and J2ME for Java applications on the phone, mobile phone. SOALIB has support for 24 different databases, which include file-based databases. And SOALIB can be run and executed from embedded systems. We have a C API, which is very tiny and does not consume a lot of space. So what is the advantage of SOALIB? As you notice that in our previous discussion, we have said that you can build services based on layering, in which each of these little layers or little services are independent services which you consume or either write or purchase them. SOALIB provides those little services for you which you can use to build your own big service. Let's see what those are. Using SOALIB to build your own services. As you can see, which we have discussed before, that you are building service A and service B based on SOALIB's core services. And let's focus on what it can do. The SOALIB services, these are all web services, have multiple services being offered. iAccount, on the core services part, these are the services you need for any kind of application. Some applications have to log into the service. It needs user administration, it needs connectivity, security, error messaging, and then update and scheduling. All of these are called core services. And there is also other utility services like load balancing, batch file, etc. And database synchronization is one of the most powerful SOALIB services offered by SOALIB, which can do heterogeneous data synchronization, which we will see later. And iPayment on the bottom is the payment credit card processing engine or payment processing engine in general that supports both credit card, debit card, check card, transfer money, etc. So let's focus on a little bit detail. We'll not go into very detail, just overview. Is iAccount is mostly related to user authentication, admin services related to account administration, for example, locking a user, unlocking a user, enabling user, disabling user, creating user, deleting user, etc. Connection is a connectivity service where you provide database connectivity, JMS server connectivity, FTP connectivity, any kind of connectivity is stored by the same one single service. Security is used to create secure tunnels. And it also uses to create certificates, which can be used for secure tunneling and other security issues, like, for example, encryption password, encryption key to be used, etc. SOALIB is a general service and can be consumed by anyone. Generally provides an overview of what features are available. Error messages is an error message service which provides you all the error messages related to a particular error code. Update service is updating services from over the internet and also provides API for users to provide their own updating software. Scheduling is to schedule various events in a periodic way. Utility services have a number of components, which is load balancing for iBalance, batching to sequence a number of operations into a batch, file operation, which can be used to access server files and load, transfer, copy operation. Report is for reporting various reports like database report, XML generated HTML report, various kind of reports can be used to generate reports. It can also be PDF format. Socket is a SOA version of the traditional Socket API, which can be used to create server socket for various purposes. iMessage service is a service which is used to communicate with other message-driven servers, for example, WebSphere, WebLogic, etc. Or it may be ESB as well, to communicate with other third-party messaging API. Mail is a service-based email API that can be used to read, write, send, or retrieve emails from any servers. So it's generally, email helps you to centralize all the mail over the web. So if you have 10 different email servers and you want to integrate into just one mail system, can be done with iMail. And this is the most powerful area where SOALIB have data synchronization service with 24 databases heterogeneously. Does not really have to be a particular platform. It can be any platform, and it can synchronize heterogeneously. Means that you can synchronize data from a flat file to an Oracle database and vice versa. Bring the Oracle database into a flat file, or can synchronize any combination MySQL to SQL Server. And it's mapper based, means that column by column mapping can be done based on this mapper. Synchronization will be applied, and the synchronization is bidirectional. It can be mixed with other databases, or it can be mixed with your own code if needed. As an example, let's say that you have two databases. One is storing the salary information, and one is storing the tax information. When you write to the target database column, you can compute the salary information with tax information and compute the tax and store the tax. This is the mixer operation which can be used during synchronization. You do not have to physically have the column into the targets. You have to have the column, but you do not have to store the values there. The SOALIB API synchronization API will provide you the computation and store the results there. And it's bidirectional. iQuery is a query engine which allows you to query unlimited number of databases, presently 24. 24 covers most popular databases, so if you have a database that we are not supported, we certainly can add that once we know that. There are a number of databases that's not supported. For example, Berkeley database is not supported, and Intersystem Cache is not supported, and Versant is not supported. These are the three databases we do not support, but most of the major ones are now supported. We are adding features to support other databases within a few months. Now, iPayment is a payment engine which can be used to process credit cards, debit cards, check cards, various others. It depends on what card you have, and also depends on what kind of service level you want. These entire SOALIB application is a server-based application which you deploy on a server. And this example shows you that there is a server running in the cloud, and the cloud exposes a number of services to you which can be consumed by embedded systems in C API, in embedded system or C++ application using the C++ API, Java application using the Java API, .NET application using the .NET API, and mobile applications using the J2ME or C API. Use SOALIB in your own on-demand solution. What really it means that if you are planning to build your own on-demand application, on-demand means that you want people to sign up and consume the service, and you bill them based on the amount of time they have used to offer consume the service. For example, let's say that you are offering some kind of service once a day. If the user signs up, then you charge that user one day, the day they have used. It can be done on a daily basis, hourly basis, or even per second basis. It's all up to you. You can use SOALIB to do this kind of on-demand application that will run from PCs, mainframes, servers, embedded systems, mobile systems, and anywhere. We provide all the API for you. And unless I go to real application examples, I don't think it will be very clear. Let's go into the examples that can be where SOALIB is used. And this is a box at the center. You see the orange box is the embedded version of SOALIB that's running in a very small 5-inch by 5-inch and 1.5-inch height box. And this box is able to synchronize or communicate with multiple mobile devices, cell phones mostly, with each other. And each of these cell phones can access one of the 24 available databases which SOALIB supports. So this allows you to access data from databases from cell applications. As application 3, should be 2 basically, shows you that embedded systems can also access databases through SOALIB. Another application is SOALIB can be used to communicate with the mainframe server as well as databases, as we shown in the previous application, that mobile and embedded system was already connecting to databases. Now we have added in this slide third-party applications and third-party SOALIB services, which can now also connect to mainframe and database at the same time as J2ME application and also C++ applications. In this slide, we're showing heterogeneous data synchronization, which is many-to-many form. A many-to-many form is when you have multiple source and a single target, and one-to-many is when you have one source and multiple target. And you can create any combination of those using SOALIB. Let's look at in somewhat detail of many-to-one form. You have source database, multiple source databases merging into a single database. So we call this operation unionization. Database union. If you have, for example, on the source side, you have Oracle at multiple sites and multiple servers. You can integrate all those data into a target server, which may be SQL server. This is called many-to-one, and it's both bidirectional. And in this example, we are focusing on load balancing. There are two SOALIB servers. One is inside firewall, one is outside firewall. And we created a tunnel from the outside firewall to the inside firewall SOALIB server. Now what happened now, after the tunnel is created, is this mobile system can now talk to the embedded, to the mainframe and SOALIB services, which was not possible before. Now this covers the applications where SOALIB can be used. We'll focus on how to provide the client side of SOALIB. SOALIB provides clients for many different platforms. All the needed libraries for this client, writing your own application client, is already provided for you. It's very easy to use. Few lines of code can do a lot of things. And if you have any questions, you can always contact us. And this provides you an email, so developer@soalib.com. And we offer free courses, and there are a lot of training available on how to use SOALIB in your own cloud applications. So this is fairly a short overview of SOALIB and cloud computing and cloud computing in general, there isn't much in cloud computing unless you have cloud application. Cloud computing provides you the platform to write applications that are scalable, and it is the application that you have to think about when you are thinking about cloud computing. Cloud provides you the platform of scalability, and you have to write applications for it. This, I think, we have reached the end of the webinar, and we are almost on time. About 5 minutes left to answer any kind of question that you might have. If you do not have any question, thanks for attending this webinar. There are 2 more webinars coming next week. And go to the website, this website, event.html, SOALIB.com, event.html. There are 2 more webinars coming, and both of them are free. And if any questions you have about this webinar, which may come up later, if you do not have a question now, you can always ask me later. And you can send email to soalib@soalib.com, and I will respond to that email if you have any questions related to this webinar or any future webinar. If you have missed any past webinar, you can always sign up soalib.com and look at the recorded video of what has been presented in the past. We are continuously offering webinars, and you can always see them later if you cannot participate at real time. This is a real-time broadcast, but we are recording this session, and we will have this session for you to review later if you like. It will be within a week or so after we finish the editing and make the video online ready. I hope there isn't any question from anybody, and I will look forward to having you in my next webinars. Thank you very much.